Hi and good day. My name is Andyclos and lalaki Boon. Today, I will present my project named Rescue Disaster Response and Scheduling using Quantum-Inspired Optimization under the supervision of Dr. Aslina Muhammad Qasim. To begin, Rescue was developed to address the disaster response coordination challenges in Penang Island, especially during the large-scale flood, landslide, and multi-agency emergency operations. Current coordination often depends on the manual communications, which can slow down decision-making when incidents and resources change quickly. So, what is Rescue? Rescue is an intelligent progressive web application or PWA that supports incident reporting, verification, real-time map visualization, resource management, notification handling, and optimized schedule generation. Public users can report incident without logging in. Station leaders can verify incident, manage resource, and generate schedules, while the station officers can view assigned tasks and receive notifications. The system uses discrete Hopfield neural network preprocessing, instant mode with simulated annealing, and extended mode with quantum approximate optimization algorithm through Qiskit. Rescue focus on Penang Islands district and align with the SDG 11 by supporting the safer and more resilient disaster response coordinations. Next, there are three main problems that Rescue aim to solve. First, disaster response scheduling is computationally complex because multiple agencies, incidents, teams, and locations must be coordinated at the same time. As the number of incidents increase, it becomes difficult for human coordinators to manually find the best deployment plan under the time pressure. Second, the limited resources such as manpower, medical teams, rescue vehicles, and equipment may be allocated inefficiently without optimizations. This can cause the wrong team to be assigned to the wrong incident, wasting time and delay critical response. Third, current condition often depends on separate communication channels, which make it difficult to update the plans when disaster evolve or priority change. Therefore, Rescue is developed to provide a centralized and adaptive scheduling platform for faster and more structured disaster response. Now, for the system objective, what Rescue wanted to achieve is to develop a disaster response scheduling module using an intelligent scheduling optimization approach. Second is to develop a web-based interface that visualizes real-time disaster incidents and deployment routes displayed on the geographical map. It is important for me to emphasize that this project focuses entirely on scheduling optimization, not route optimization. While the map displays the path, it is intended strictly for situational awareness and use the default setting of the map provider. This allowed the coordinator to see incident locations and the station markers without the system calculating customized off-road path or complex vehicle-specific routing. And finally, is to develop a web-based dashboard for a coordinator to manage real-time disaster updates and trigger schedule re-optimization. Next, let's talk about the three main modules of the rescue. The first module is the Intelligence Disaster Response Scheduling module. This is the core optimization part of the system where the station leaders can generate the schedule using the instant mode with the simulated annealing or extended mode with QAOA. The second module is the Real-Time Geographical Map module. This module displays the disaster incident response station, incident details, and deployment routes on the map. This route is shown for visualization purpose while the main focus of rescue is scheduling optimization. The third module is the Informative Disaster Management Dashboard module. This module supports the login and logout, incident reporting, dashboard statistics, resource management, user and agency management, and notification alerts. Together, this module allows Rescue to support reporting, monitoring, coordination, and optimize disaster response scheduling in one platform. After that, this is the system architecture of the Rescue. The system uses a multi-tier architecture that separates the front-end, back-end, database, and external services. On the front-end side, Rescue is developed as the progressive web applications using the React.js, so it can be accessed through the desktop, tablet, and mobile devices. It also provides a different interface for the administrator, station leader, station officer, and the public user based on their responsibilities. On the back-end side, Django is used to manage the system logic, which include the authentications, incident processing, resource management, and schedule generation. Firebase is used as the NoSQL database to store incidents, resources, schedules, users, and notifications while also supporting the real-time data synchronization across the dashboard. For the external services, the system uses the Google Map API to display the incident locations, station markers, and route visualizations. The optimization component runs the intelligent scheduling algorithm, which include the DHNN preprocessing, simulated annealing, and locally simulated QAOA through the Qiskit. The optimized result is then returned to the front end and displayed as the readable deployment schedule. After that, let's move on to the proposed solution of the Rescue. Rescue provides several core functions to support disaster response coordination. Users can report incident with location, severity, casualty range, and photo evidence. The nearest station leader will be then notified to verify the incident before it is used for the scheduling. Station leaders can also manage station resources such as manpower, vehicles, and equipment. After that, the system supports real-time dashboard monitoring, live map visualization, route display, notification delivery, and optimized schedule generation. For the intelligence scheduling part, the system first fetch the verified incident data and available station resource from the Firebase. Then, the HNN preprocessing is applied to generate a better initial assignment or the candidate pool. Each possible assignment is evaluated based on the severity, distance, station capability, casualty range, medical needs, and manpower availability. After that, the station leader can choose instant mode, which is use the simulated annealing for faster scheduling, or extended mode, which use the QAOA through Qiskit for advanced quantum-inspired optimization. The final result is decoded into the readable deployment schedule and then displayed on the dashboard and the scheduling page. For the algorithm testing, I use a test dataset with 4 incident types, which are the fire, flood, hazardous material, and the landslide. Among these incidents, 2 have casualties and 2 have zero casualties. This is important because I wanted to test whether the system can correctly assign the medical teams only when they are needed. The resource dataset include available 15 stations and 45 personnel from the Bomba, PDRM, APM, and medical teams, which are St. John and Red Crescent. For the simulated annealing, the finalized parameters are initial temperature 100, minimum temperature 0.1, cooling rate 0.9966, and maximum iteration 2000. For the QAOA, the finalized parameters are the Kobila optimizer, circuit depth 1, and the maximum iteration 500. Based on the result, simulated annealing with DHNN preprocessing achieved an average objective score of 138.85 with only 1679 milliseconds. Meanwhile, the QAOA with DHNN achieved a higher average objective score of 223.46 but required a longer computation time of 43420 milliseconds. Therefore, simulated annealing is selected as the instant mode because it is faster for urgent response, while KOA is selected as the extended mode because it provides a more advanced quantum-inspired optimization result. For the impact and benefits, Rescue helped improve disaster response in the 4 main ways. First, it supports the faster decision making by reducing the manual planning delays and generating optimized schedule using the instant mode and extended mode. Second, it improved the resource allocation by assigning limited manpower, medical teams, vehicles, and equipment based on the important factors such as the severity, distance, station capability, casualty range, and availability. Third, Rescue improved the multi-agency coordination by centralizing incident reporting, verification resource update, notifications, dashboard monitoring, and live map visualization for the agencies such as Bomba, PDRM, APM, and medical teams. Lastly, the system provides a real-time situational awareness through the dashboard and Google Maps integration, allowing users to monitor incident locations, response stations, their deployment routes, and assignment status in real time. Rescue has entrepreneurship potential because it can be offered to the Penang state government as a centralized disaster response coordination platform. In this model, the Penang state government can act as the main system administrator to register and manage participating agencies, response stations, and station leaders' accounts in one platform. This direction is inspired by the existing state-level digital platforms such as the Pages or Penang GeoHub, where the digital systems are used to centralize important geospatial information and support government services. Similarly, Rescue can support Penang government by centralizing disaster incident reporting, agency coordination, resource monitoring, and optimized deployment schedule in one system. After the initial deployment in Penang Island District, Rescue can be expanded to the other district in Penang and later adapted for wider disaster response coordination in Malaysia. The Rescue commercial value is that it helps to reduce the manual coordination time, improve the manpower allocation, support real-time monitoring, and generate optimized deployment schedule during the emergencies. For the business model, Rescue can use a tier pricing approach. The instant plan provides an instant mode using the simulated annealing for the fast and practical schedule generation at a lower cost. The full optimization plan provides both instant mode and extended mode, allow user to choose between the simulated annealing and QAOA for advanced quantum-inspired optimization.
Now, let's move on to the system demonstration. The interface here is shown in the laptop device. For the rescue system, user can choose whether want the light mode or the dark mode. Now I will try login as the admin. Sign in. This is the admin view. For admin dashboard, admin can view the dashboard statistic and the active incident list. For admin, they can register new agencies. For example, create an agency Bomba, then create the agency. Here is a new agency created, which is Bomba. Inside the Bomba agency, the admin can add the several stations under the Bomba. Then save the station. The newly created Bomba station is created here. The admin can view the Bomba locations, also can edit the station information, also can delete the station. Besides that, admin also can register the response team leader user account for any station under any agencies. After create the account, the admin should send the credentials to the leader. For the Rescue Progressive Web application in mobile phone, user can install the Rescue into their phone. After installed, the Rescue icon will appear in the mobile home screen. Now try to log in using the newly created leader account just now. Log in successfully into the newly created leader account just now. Now in tablet view, I will act as the public user to demo for the report incident form. Fill in the report incident form. Input the location of the incident. Then add the photo evidence. The photo evidence will extract its metadata to maintain the integrity of the evidence. Now submit the report. After the report is submitted, the notification will be sent to the nearest station leader of that incident. Now back to the mobile phone view. Now as you can see here, the nearest station leader of the incident have successfully received the notification. They need to go to the incident location and verify the incident is correct before the incident can be used into the scheduling engine. Inside the leader view just now, leader can view the notification, can update their availability status, can see their profile, can reset the password, can log in using the newly reset password, can view the dashboard, their assignment status, can manage their station, can view the statistic of their assigned stations, can view the list of active incidents. Leader also can view the live map, can view their current location, can navigate the route to the incident from their current location. Leader also can view the disaster reports incidents list. The status of the newly reported incident will be shown as reported. This is the incident that reported by the public user just now. Inside have the incident details. This leader can verify and edit the information of that incident after they go to the incident location. Save the incident edits, can view the evident photo, zoom in, zoom out. After everything is confirmed and verified, the leader can click the verify button here to verify the incident. Can put any remarks. Now, the status of this incident is already set as verified. This incident will be used inside the scheduling engine. Then the leader can go to the schedule page to generate the optimized schedule. The leader can choose either want to use the instant mode or extended mode. The instant mode is using the simulated handling algorithm, while the extended mode is using the KOA algorithm. This is the result of the instant mode. The leader can view the generated schedule at the below. The appropriate station and manpower is assigned to that incident. The leader also can export the generated schedule as PDF or Excel format. The leader also can click the verify button if they are satisfied with the generated schedule, or click the reject button if they are not satisfied. This is the result for the extended mode. As shown at below, appropriate 2 station is assigned to this incident only. Leader can also verify or reject the schedule. Verify. So the listed station and the officers will be assigned into this incident. For the assigned officer or leader, in their dashboard, they can view the assignment status. They will assign to which incident and where is it. They can view the live map visualization route in the dashboard also. Also can open in the Google Map. Also can click inside to the assigned incident. Only the station leader can update the dispatch status. If the incident already resolved, only the assigned leader can click the mark resolved here. And need to wait for the other station to click the mark as resolved. Only for this incident status can become closed. After the schedule is assigned to the selected officers, their availability status will automatically become dispatched. The leader also can view the agency page. In the agency page, the leader only can manage the resources of their own station. The leader can add the resource for their station and save the resources. They can view the resources of their station, can update the information of their resources, can delete the resources. The leader also can manage user, which is only can manage the officers that under that station. The leader can add new officer account that under his station, and create the account for the officer, then send the credentials to the officers. Let's try to log in using the newly created officer account just now. The responding officers also can view the dashboard, can view the assignment status, can view their station information and statistic, can view the active incident list, can view the live map also, can view the disaster information, but they cannot update the status of the incident. Can view the schedule page, but they cannot generate the schedule. They can only view the schedule. They can view the agency, can view their own or others agency or stations, but they cannot edit or delete the information of the resources. They can report the incident also like other users, which their full name and phone number is already automatically recorded. That's all for the system demonstration for Rescue.
To conclude, Rescue successfully achieved its objective by developing 3 core modules, which are intelligent disaster response scheduling, real-time map visualization, and informative disaster management dashboard. Based on the testing, the main functions such as the incident reporting, verification, resource management, notification, schedule generation, and role-based access work successfully. For the algorithm result, simulated handling is suitable for instant mode because it is faster, while QAOA is suitable for extended mode because it provides a more advanced quantum-inspired optimization approach. For the future of the rescue can be improved with the offline support, real-time GPS tracking, IoT integration for real-time resource tracking, advanced route optimization, larger scale testing, and possible education on the real quantum hardware. That's all for the rescue system presentation and demonstration. Thank you.